Hello everyone. This video will explain the properties of the CollidorBase class. First, let's look at what a collider is. A collider is a shape component used to detect collisions. In the previous video, we introduced rigid bodies. Rigid bodies serve as carriers for colliders, defining the physical properties of an object, while colliders define the collision shape and physical characteristics of the rigid body when interacting with other objects. The actual collision detection and response are performed by the colliders. Without a collider shape area, only having a rigid body will not produce collision effects. Therefore, when using the collider component in Layeride without adding a rigid body component will be automatically added. There are 5 types of colliders in total: circle collider, box collider, polygon collider, edge collider, and cane collider. The layer engine and IDE are based on the shapes of the Box 2D physics engine, and encapsulate colliders that are easier to understand and use. All colliders inherit from the base class CollidorBase, and share common base class properties. The common properties of the 5 types of colliders are offset, friction, restitution, density, is sensor, and label. Each collider also has an edit shape button. Next, we will introduce these common properties one by one. Offset refers to the offset value of the collider shape relative to the coordinates of its parent node. The default values of x and y are both 0, which means they are consistent with the node coordinates. For example, in the image, the yellow border is a rectangle collider, and its x offset is 50 and y offset is 60. In Layer IDE, change the offset of different colliders and observe the effect. The yellow border represents the collider shape. The friction describes the magnitude of resistance to relative sliding between two contact surfaces. It ranges from 0 to 1, where 0 means no friction and 1 means strong friction. Smooth surfaces like ice have smaller friction, while rough surfaces like rubber have larger friction. For example, 3 blocks with the same mass slide down a slope simultaneously, with friction is 0, 0.5, and 1. The smaller the friction, the smoother the slope surface. The restitution describes the elastic property of an object during a collision. You can imagine playing table tennis or basketball, where the restitution characteristics make them bounce out or up. If the restitution is 1, it means the collision is completely elastic, and the object will bounce back at the same speed after the collision. If the restitution is 0, it means the collision is inelastic, and the object will stop after the collision. For example, 3 circles with the same mass fall simultaneously, with restitution is 0, 0.5, and 1. You can see that the larger the restitution, the better the elasticity. The density defines the mass per unit area of an object. In reality, density is the ratio of an object's mass to its volume. However, in a 2-dimensional world, due to the lack of one dimension, area is used instead of volume to simplify calculations. Properly setting the density is crucial for achieving realistic physical simulations. The default value in the IDE is 10. The density value can be 0 or a positive number. If it is 0, regardless of the shape's area, the mass will be 0. This will make the physical response similar to a static rigid body, unaffected by external forces or gravity. The density value is usually a positive number. The larger the density value, the greater the mass under the same area. An excessively small density may cause the object's behavior to be unstable, while an excessively large density may result in a huge mass and greater computational cost. It is important to note that when multiple objects are stacked together, it is recommended to use similar densities, as this can make the stacking more stable. Next, let's demonstrate the effect. 3 circles with the same area, but different densities of 0, 10, and 50 will collide for comparison. When the interaction logic needs to determine whether 2 colliders have collided, but does not require a collision response, this can be achieved through sensors. By checking this property and setting it as a sensor, it can detect collision events with other objects, but will not produce a physical collision impact on those objects. This property can be used to monitor whether a character has reached a specific area, causing changes in game behavior, or to trigger specific effects such as sounds and animations. For example, there are 2 squares with the is sensor property checked. Run and observe the effect. The 2 squares do not display a collision, but the physics engine actually detects the collision event without displaying it. The label of a collider is used to find and identify the collider in script code. You can customize the label name for a collider, such as Box Collider 1. Next, let's look at an example of label. The black box collider has a label of Box Collider 1, and the red box collider has a label of ground. Add a script to the white sprite, and add a collision event on trigger enter. Collision events will be explained in later videos. So for now, just have a general understanding. When the white sprite collides with the black box collider 1, it prints collided with box 1. When the white sprite collides with the red box collider ground, it prints collided with the ground. Run and observe the effect. When colliding with Box Collider 1, it prints collided with Box 1. When colliding with ground, it prints collided with the ground. Finally, there is the Edit Collider Shape button. Clicking it will make the collider enter a visual editing state in the scene panel, allowing you to offset its overall position or change its width and height. For example, using a box collider, click to enter the editing state, and then you can perform the corresponding operations. When the mouse leaves the range of the collider and node, the editing mode will automatically exit. To edit again, you need to click the button once more. That concludes the introduction to the common properties of colliders. Thank you.